Covering high power devices. So basically the basic setup you'd need in order to power something that's, let's say, a higher voltage or requires more current than an Arduino can supply. So basically first off we'll start with a breadboard, because we're going to need one of those. We'll take an Arduino Unio. Bring that down a bit to make things a bit easier. We're also going to need an external power supply. This. Oh, one basic. Let's go to all. See if we can find it this way. What we got. This same thing would go for the same as if you was going to use like a 9-volt battery as well. Power supply. Yeah, we'll just use this one. We'll use this one, a basic power supply. So we're going to control something that's going to be obviously a higher voltage, probably a higher current than an Arduino can supply as well. Light bulb. What voltage is that? Is there any information on that? There we are. So it's a 3 watt, 12 volt incandescent light bulb. So we'll, I'm just trying to think where to put it. I'll put it up here. There's your terminals. Terminal 1 and 2, because it's an incandescent, it doesn't matter which way the positive negative go. But this will apply for like relay boards, or anything really. Anything that requires a higher current. So what we'll do is, first things first, is we'll wire the power supply up. So basically you want to take your negative and we'll plop that into the ground there. The positive, I'm going to send that out to the breadboard on this rail here. Or should I go from the bottom? I'm just trying to keep this as simple as possible. I think what I'll do is I'll go from the bottom. So we'll block that in there. Change that to red. Okay, so now we're going to need where are temperature sensor? We'll start off with a basic transistor, quite common one, so an NPN type, if I can find one, that is. Pretty sure, oh there we are. So there's an NPN type transistor. So you've even got the pins marked out for us, but I'm going to put it up here just so you can see the connections. It tells you the port. So the most common setup is collector, base, emitter. Some might be base on this pin here. So basically your emitter pin on an NPN type transistor always goes to ground, so your ground rail. Tell you what, I won't put that there. Just delete that. I'm going to tie it into this rail here. Change that to black. Also on these breadboards, as you can see, these are all connected in rows this way and then columns this way. That's how breadboards are normally designed. So we want negative, so we'll take a negative from the Arduino here and we're going to come down to the negative part of the rail. Oh, I need to change that, don't I? I'll change that to black. So I'll make a first connection here, which is obviously going to be for the connection for your emitter here. We'll now connect the Arduino. Resistor. We're going to need a resistor. This is a 1K at the moment, so I'm going to change that to a 10K resistor, which is the most common, because they don't require a lot of current to, a lot of power to switch them. Let me just, I can't turn that on yet. So what I'm going to do is I'm going to set the voltage on there. So we'll set that to 12 volts. So that's set up. So we've got the bulb this side. So we'll take a ground connection. We'll put it on this side. So what I'm going to do is I'm just going to straight up to this rail here to connect that one up. Connect. Like so. So that's that one plumbed in, and then that's already connected to there. So now we need a signal, so we use digital pin 3, and we'll leave this one green. Let's go this way, go round to the bottom. Obviously these aren't going to be connecting to the board itself, they're going to go straight to the pin which is there. It's not going into these rails, and that will give us our signal for the base of the transistor, because the MPN, so it's negative, positive, negative. Now we need the output from there, so we'll take a negative from there to there. I also need to change this because that doesn't need to be in there. That's my mistake, because it'll be getting it through the emitter here, you see. So I don't know why I did that. And then we want our positive, which is going to come from the positive rail. We'll take that from here and we'll go straight onto the positive rail here. Change that to red, like so. I think that's pretty much the setup for this bulb. Remember, this is bulb's 12 volt, and obviously this is only a 5 volt, and we're not using the 5 volt, as you can see. We're not using any power from this board. So now what you want to do is we need to get the code out. We need to get rid of that and go to text. Get rid of this. We'll start from scratch. So first things first, we need our signal, which is going to the transistor. So we'll just call it SW. Oh, helps if I do that first. SW. We'll just start lowercase, and then equal to the pin that we're using. So it's going to be equal to 3, and then that. So SW3. Like that name there can be anything you want. It's just so whoever's writing the code knows what it's actually doing. So you could call it switch, you could call it whatever you're actually setting it to. We now also need to do the pin mode for this to activate it. So we type pin mode. I'll put node, no, I'll put mode, there we go. So set SW, lowercase, and we want to set that as an output, like so. And then we obviously want it to do something, so what I'm going to do is just a digital write. And we'll set it high. We're going to add a delay, because obviously we want it to change its status, so we'll put on for a second. You don't need the delay. If you just wanted to turn it on, you could quite easily do that. So we've got a delay in there. I'll tell you what, I'll bring that down to there, and then we want a digital write again. So just hit the caps button. And that's going to be SW, and then we're going to set that low, and then we'll add one more delay just to make sure it turns on for a second and then turns off for a second. So I'll just copy that, drop down, and add that delay there. Now once you start the simulation, should flash this bulb on and off basically every second. So we'll run that, and as you can see, it's no different. It's literally how you'd do it. Well, it's how I'd do it anyways. I can't move this out of the way. Let's just bugger it off like that. And obviously if you drop the voltage, if you bring the voltage down, you'll see the bulb actually gets dimmer, which it would do in real life anyways. I don't know how it's managing to run at 1.2 volts. I can't really see that happening. You'd probably just get well, you wouldn't even get a glow, to be fair, but you notice the current's gone down. So you can run these. You could probably run this with a thingy, but it would drain the battery. So like a 9-volt battery you could probably get away with. And that's just how you'd use an NPN. You could swap that out and use a MOSFET. The reason you'd use a transistor is if you use because we're using the PWM pin there, we could actually pulse width modulate this in order to control the brightness of the bulb. Obviously if you use a MOSFET, you could probably still do it, but it might be choppy because MOSFETs are either on or off. But they do allow for a lot more current, whereas a transistor would probably heat up and go bang bang. So yeah, so this applies for anything, even if you was using like a relay board. Like your basic power setup for powering the bulb would be similar to this. So obviously your negative wouldn't be connected directly to the bulb, because otherwise that would just constantly turn it on, which is the reason we're taking it back to the negative here. And then obviously we'll be connecting it through there. So it's only connecting through the 2 pins there, just to give them all a voltage reference. That shouldn't harm the board either, because it's just going from out one pin and into another. So yeah, that's simply how you'd power something a lot higher voltage. Obviously we can crank this voltage up here, and it'll warn you. So 13 volts, it's kind of okay. It's getting brighter. Go a little bit higher. We're at 15 volts now. We'll just keep cranking this up. I don't know why, but it's still taking. Normally it'd show heat here as if it's getting hot, but for some reason it isn't doing it. I'd imagine this would be getting hot now at 22.2 volts. The current isn't too high, even though it's maxed out here. So yeah, I'm surprised it hasn't actually overloaded. It would have done. It's probably would have blown by now. So yeah. But that's the simplest way you'd do it, and obviously the codes, it's pretty much, you just all you're doing is setting up your pin for your output. So you set, that first part's just setting up this pin here, digital pin, which is this part. That's what the 3's for. And obviously when we're setting it to pin mode, that's activating that in the Arduino, in the controller itself, to, you know, give that pin a function. And then basically obviously we're just turning it on and off, which is the high and low, for 1 second. So you could change, like, this would be no different from a relay. The only difference is when you're using a relay, obviously if you've got buttons, you'd be using like a function, which is where your if statements and things like that come in. So yeah, so this is how easy it is really to use a higher voltages in order to power the bulb. So we'll quickly stop the simulation, and we'll try the same thing, same bit of code. We'll just remove this time, and we'll look for a 9-volt battery. If we got a 9, oh, here we are. We got a 9-volt here, so we'll use a battery instead. It tells you your negative and your positive terminals. So it'll just be the battery to the ground on the Arduino. Change that black. Power down to your rail or directly to the bulb, it doesn't really matter. Obviously we're using a breadboard, which is the only reason I'm using this rail, because if I wanted to add anything else I could just tap into this and use the same supply voltage. And then what we're going to do now is start the simulation again, and the bulb's flashing again. And you know what I mean, it's just whatever your supply of voltage is, it doesn't matter whether it be, I mean, it needs to be at least 12 volts because it's a 12-volt bulb, or roundabouts. You could probably get away with between 10 and 12 volts. Anything after that, anything lower than that, should I say, it's going to start to get dimmer, and obviously anything higher than that, it will get brighter, but you've got a good chance of breaking the I can't think what that's called, that filament thing inside. So yeah, plus obviously when you're doing this, you want to check that this isn't getting hot. Depending on the transistor and what maximum currents, you can always find that out on data sheets. You just literally Google the part number that's on there, and type pin outs or data sheet or anything like that, and you'll get that information, like what pins, which is your collector, base and emitter, and it'll also tell you its current ratings, its peak ratings, things like that. So yeah, so thanks for watching, and I hope that solves some problems and some headaches for people. Thanks for watching, and have a good one.